We've always looked up, long before we built telescopes, before we mapped orbits or whispered into satellites. We stared into the stars with a quiet ache we couldn't name. Not for beauty, not for meaning, but for presence. We've asked the question 1,000 different ways, in stone and scripture, in science and silence. Are we alone? Tonight, we trace the shape of that question, not through myth, but through math, through probabilities, paradoxes, scales of civilization and survival. We'll follow a quiet equation that tries to count the uncountable. We'll confront the paradox that dares to ask, if they're out there, why haven't we heard them? And we'll climb a ladder of power so vast it reshapes our understanding of what life could be. Not just on other planets, but in our own potential. But this isn't just about aliens. This is about us, about what kind of species we are, and what kind of species we might become if we survive the test. Because maybe the silence isn't empty. Maybe it's waiting for a signal, not in radio, not in light, but in the choices we make, right here. The Drake equation. We begin not with a telescope, but with an equation, a quiet string of symbols that, on the surface, resembles the mathematical murmurings of any mid-century chalkboard. But beneath its simplicity lies one of humanity's most profound attempts to answer an ancient question. Are we alone? In 1961, in a conference room beneath the pine canopies of Green Bank, West Virginia, a small group of scientists gathered in a moment of clarity that still echoes today. There, Frank Drake unveiled a formula that was not designed to solve a problem, but to provoke a conversation. The Drake equation. N equals R star times Fp times Ne times Fl times Fi times Fc times L. Each variable a mystery, each component a step deeper into the unknown. Let's unpack it. R star is the average rate of star formation per year in our galaxy, a number surprisingly stable, hovering around 1.5 to 3 new stars per year in the Milky Way. Multiply that by Fp, the fraction of those stars that have planets. Thanks to the Kepler Space Telescope and other exoplanet missions, we now estimate Fp is close to 1. Almost every star you see in the night sky likely has at least one planet. Ne is the number of those planets, per star system, that could support life. The habitable zone, a delicate orbital range where liquid water might exist. Not too hot, not too cold. Earth is our template. Mars and Europa are borderline cases. Some researchers now suggest Ne could be 0.4 to 1.2, depending on how broadly we define habitable. Fl is the fraction of those worlds where life actually arises. Here, our certainty collapses into speculation. On Earth, life began almost as soon as the conditions allowed, within a few 100 million years. That implies Fl might be high, but we have only one data point. For all we know, that early spark was a cosmic miracle. Or it could be a universal inevitability. Fee asks how often life becomes intelligent. Not clever, not social, intelligent. Able to use tools, create symbols, peer into atoms and stars. On Earth, life flourished for 3.5 billion years before intelligence as we define it arose. Was that delay necessary? Or a fluke? Did the dinosaurs need to vanish to make room for minds? Fc is the fraction of intelligent civilizations that develop detectable technology. Radio waves, city lights, neutrino pulses, anything we might pick up. Here we ask, how often does intelligence broadcast? And finally, L, perhaps the most haunting term of all, The average lifespan of a technological civilization. How long do they last? How long until they destroy themselves, retreat into silence, or transcend communication altogether? Multiply all of these, and you get N, the number of civilizations in our galaxy capable of communication at this very moment. Estimates vary wildly. Plug in optimistic values, and you get 10,000 communicating civilizations. Use conservative numbers, and N shrinks to less than 1, suggesting we may be the only spark currently burning. But here's the twist. Even if N equals 10,000, our galaxy is vast. So vast that the nearest civilization could be thousands of light years away. Their signals, even traveling at light speed, would take millennia to reach us. We might be hearing the long-dead echoes of their golden age, or we might be shouting into a void yet to reply. The Drake equation does not give us answers. It gives us a frame, a lens, a way to hold the weight of uncertainty and still proceed with wonder. And yet, for all its brilliance, the equation leaves us with a problem, a paradox. The Fermi Paradox. It is a crisp afternoon in the summer of 1950. Physicist Enrico Fermi, one of the minds behind quantum theory and the atomic age, is walking with colleagues near Los Alamos National Laboratory. Their conversation drifts toward the possibility of extraterrestrial life. How many stars there are, how many planets might orbit them, and the age of the universe itself. At some point, Fermi famously pauses and asks, "But where is everybody?" It's not a question about faith. It's a calculation of probability versus presence. The Fermi Paradox is the tension between the high likelihood of intelligent alien life in the galaxy and the complete lack of evidence for it. If our galaxy alone may harbor thousands, possibly millions, of potentially habitable planets, and if intelligent life could emerge on even a small fraction of them, and if just one such species developed star-faring technology millions of years ago, then logically, they should already be here. And not just here in the poetic sense. They should have colonized the galaxy, built monuments we could see, left footprints in the dust of moons, filled the dark with signals. Yet we see nothing. We hear nothing. There is only silence. This paradox slices through optimism with a scalpel of logic. Let's explore the explanations, grouped into broad categories. 1. They are rare. Maybe intelligent life is exceptionally rare. Earth might be a statistical miracle, an oasis in an otherwise barren universe, a product of just the right ingredients at just the right time, stirred by luck and stabilized by a magnetic field, plate tectonics, and a large moon. In this view, the Drake equation's FL, phi, and FC values are vanishingly small. Life may be common, but intelligence, civilization, radio, spaceflight, maybe not. We could be the first. 2. They are quiet. Perhaps intelligent life is common, but chooses silence. Maybe civilizations go through a brief, noisy phase, broadcasting radio waves, exploring nearby planets, before turning inward, toward digital thought, virtual realities, whispered communication through quantum entanglement or neutrino pulses we haven't learned to hear, or maybe they fear being heard. Perhaps the galaxy is not safe. Perhaps the first rule of intelligent life is don't broadcast your location. This is sometimes called the dark forest hypothesis. The galaxy is a forest at night. Every civilization, a lone camper, quiet and tense, not sure if the rustling in the distance is the wind or a predator. 3. They are gone. Another possibility, civilizations emerge and then vanish. The lifespan L in the Drake equation is short. They build cities, reach for the stars, and collapse. Victims of war, ecological destruction, runaway AI, or apathy. Maybe intelligence is inherently self-limiting. There could be ruins scattered across the galaxy, dead satellites in orbit, silent cities beneath alien suns. But we're too late. Their moment came and went, and perhaps that moment awaits us too. 4. They are here. There is a more unsettling idea. Maybe they are here, but we don't see them. Maybe they've mastered stealth, hidden behind camouflage, uploading into forms we mistake for natural phenomena. Maybe they're observing us like we observe gorillas, hands-off, quiet, distant. Maybe Earth is under quarantine, a protected reserve. This is the zoo hypothesis, and it's disturbingly plausible. After all, we have only just begun to leave the cradle. We are still fighting over imaginary lines on a rock, still barely understanding our own biology, still arguing over whether we are alone. Would a civilization a million years ahead of us even consider us ready? 5. We are looking wrong. Perhaps the issue is with us. We assume that alien life will be technological in familiar ways. Radio signals, megastructures, starships. But advanced intelligence may not follow our trajectory. What if their communication is chemical, dimensional, gravitational? What if they moved beyond biology? What if the universe is filled with post-biological entities that think at the speed of light, communicate in neutrino entanglement, and explore the cosmos by manipulating the fabric of space-time itself? We wouldn't know where to begin looking. The Fermi Paradox haunts every telescope and antenna on Earth. We listen, we search, we estimate the odds, but the silence holds. And yet, it may not be silence at all. It may simply be that we're not yet speaking the right language. We are toddlers with walkie-talkies, searching for symphonies. To understand what kind of civilizations might be out there, and what we might become, we need to shift our gaze from equations and paradoxes to a scale grander than any planet. We turn next to the stars themselves. The Kardashev Scale. To grasp the path ahead, we must measure ourselves against the stars, not in size, but in capacity, in reach, in hunger for energy. In 1964, Soviet astrophysicist Nikolai Kardashev proposed a scale to classify civilizations based not by philosophy, culture, or biology, but by energy consumption, by how much raw power a species can harness and use. This was not a ranking of ethics or wisdom, but of capability, of command over the forces of nature. It is called, quite simply, the Kardashev Scale, and it unfolds in stages, like rungs on a cosmic ladder. Type 1 civilization, planetary. This is the first threshold, a species that can harness all the energy available on its home planet. That means everything. The sunlight hitting the surface, the winds and tides, the geothermal heat under the crust. Total mastery over atmospheric systems, oceans, tectonics. Nothing is wasted. Every watt is used with precision and purpose. Earth, at present, is not type 1. We are estimated to be around type 0.73. Our energy consumption is in the range of 18 terawatts. Impressive, but still a fraction of Earth's potential. To become type 1, We would need to increase our energy use roughly 10 to 100 times, while also achieving total control over it. That includes managing climate, preventing natural disasters, optimizing planetary biospheres, and achieving global coordination without collapse. Some say reaching Type 1 is the most dangerous phase in any civilization's history. It requires solving the twin demons of self-destruction and planetary destabilization. If we survive that, we ascend. Type 2. Civilization, stellar. Now imagine a species that can harness the full energy output of its star. Not just a fraction, not solar panels, all of it. This is the domain of megastructures, like the hypothetical Dyson sphere, proposed by physicist Freeman Dyson, a massive array of orbiting collectors, enshrouding a star to absorb and convert its energy. A Type 2 civilization is no longer planet-bound. It reshapes solar systems, builds colonies across moons, asteroids, and orbits. It manages stellar weather, channels solar flares, and perhaps even begins manipulating gravity itself. Such a civilization may live in space-based habitats, their populations spread out across orbital rings, computational arrays, and vast artificial biospheres. They may look at planets the way we look at caves, quaint but limiting. We have never detected a Dyson sphere, but we have tried. SETI researchers have scanned for infrared excess, the thermal signature of a star partially cloaked by collectors. So far, nothing conclusive. But even silence tells a story. Either they are very rare, or they are very quiet. Type 3. Civilization, galactic. Now we enter territory that borders on myth. A Type 3 civilization can harness the energy of an entire galaxy, billions of stars. Such a species would no longer evolve biologically. It would be post-organic, likely operating as a distributed intelligence, its consciousness encoded across thousands of systems. They would manipulate stars the way we move satellites, reshape nebulae, collapse gas giants for fuel, perhaps even engineer black holes, the most efficient engines in the universe. A galactic civilization would be almost indistinguishable from a natural force. It would move on timescales we cannot comprehend. Its artifacts might be star clusters reconfigured into logic gates, or dark matter shepherded into containment lattices. We may have already seen them and not recognized them. Such a civilization would likely be invisible to us unless it wanted to be seen. Type 4. Civilization, universal. Kardashev's original scale ended at Type 3, but theoretical physicists and futurists have extended it. A Type 4 civilization would harness the energy of the entire universe, tapping into the power of galaxies, dark energy, quantum fields. They would manipulate space-time itself, jump between universes, if such things exist, and perhaps create simulated realities as intricate as our own. To us, they would appear godlike, not in the spiritual sense, but in scale, reach, and control. They may dwell in dimensions we cannot perceive, or exist outside of time entirely. If we are bacteria, they are symphonies. But here's the twist. The gap between each type is logarithmic. That means every step up is not twice as powerful. It's billions of times more powerful. It's the difference between a candle and the sun. We are not yet Type 1, but we dream of it. And that dream is a choice. A species does not become planetary or stellar by default. It must decide to evolve, to cooperate, to build not just power, but stewardship. Because with great energy comes great responsibility, and every step up the scale carries risk. The Kardashev Scale is not just a measure of potential, it is a test. The great filter and the narrow road to Type 1. There is a quiet pressure building behind the Drake equation, a hidden weight lurking between the lines of the Fermi Paradox. It is not a question of where they are, but why they may not be. And it has a name: the Great Filter. This concept, introduced by economist Robin Hanson, suggests that somewhere along the path from the first flickers of life to a civilization that spans stars, there is a barrier, an obstacle so immense, so absolute, that most civilizations do not survive it. Think of evolution as a staircase. Each step represents a critical threshold: the emergence of life, complex multicellular organisms, intelligence, language, technology, planetary control, interstellar expansion. A species must pass every one of these to reach Kardashev Type 2 or 3 status. But what if most civilizations get stuck or fall on just one of those steps? That step would be the filter. And the terrifying thing is, we don't know if we've already passed it or if it's still ahead of us. Possibility 1. The filter is behind us. Perhaps the origin of life itself is so improbable that it has only happened once, or maybe complex multicellular life is vanishingly rare, or perhaps intelligence is almost never favored by evolution. If that's true, then we are rare, maybe even unique. We passed the great filter already. We are the winners of a cosmic lottery, a miracle not likely to repeat. In that case, our solitude is a sign of our specialness, not our impending doom. This is the optimistic scenario. It says, we made it. Now all we must do is endure. But there's another possibility. Possibility 2. The filter is ahead. Maybe life is common. Maybe intelligent life even arises often. But civilizations hit a wall. Maybe they all destroy themselves through nuclear war, runaway AI, or ecological collapse, stagnate and lose the will to explore, succumb to misinformation and madness, fail to coordinate on planetary scales before they burn through their biosphere, trigger technology they do not understand, opening doors they cannot close. If that's the case, the silence we observe may be the echo of millions of dead civilizations, each extinguished before it could reach the stars. The galaxy may be littered not with starships, but with tombs. In this model, Earth is racing toward the filter right now. And the question becomes, can we beat it? The narrow ascent. To reach Kardashev Type 1, we must thread the needle between power and responsibility. The threshold is not technological. It is moral, psychological, and political. We must create sustainable energy systems that serve the whole species, solve the global coordination problem without descending into surveillance or tyranny, preserve biospheric integrity while increasing energy consumption, avoid existential risks from AI, biotech, nanotech, or climate change, ensure that our knowledge outpaces our capacity to self-destruct. In short, we must grow up, fast. We are the only known species that can predict its own extinction, and maybe the only one capable of preventing it. But will we? The Great Filter is not a monster that descends from the sky. It is subtle, slow, structural. It works through neglect, delay, tribalism, arrogance. It whispers, "You have time," until time runs out. signs of passing through. If we survive the next few centuries without collapsing, some signs will begin to emerge. Earth's atmosphere will stabilize, not by reverting to a natural state, but by design. Humanity will act as a single ecological steward. War will become obsolete, not because of morality, but because it will be strategically useless in a globally networked system. Artificial intelligence will be aligned, cooperative, and integrated into decision-making, without enslaving or replacing us. New institutions, planetary, digital, decentralized, will rise to mediate trust at scale. These are not utopias. They are minimum requirements for survival at the next level. The view from the filter. If there are alien civilizations out there who survived this phase, they may be watching us, not with curiosity, but with reverence. They know how hard it is. They remember, they endured. And perhaps they wait, not to interfere, but to see if we are worthy of contact. Or maybe they do not wait at all. Maybe they left us alone on purpose, because only those who pass through the filter unaided are ready to join a larger dialogue. A dialogue not of noise, but of maturity. Becoming Type 1. In the quiet hours of night, when the hum of the world grows soft and the stars begin to glow through the folds of atmosphere, there's a moment, brief and fragile, when we can feel the weight of what we are becoming. We are a species in transition, balancing on a knife's edge between extinction and expansion, between noise and signal, between adolescence and something more. The Kardashev Scale is often spoken of as a ladder of power. But what if it is something deeper? What if it is not only about energy, but about ethics? Not about how much we control, but how we choose to wield it. The Earth as interface. To become a Type 1 civilization is not to conquer the Earth. It is to merge with it, to realize that our planet is not just our cradle, but our interface with the cosmos. The atmosphere is not background. It's a boundary condition. The climate is not scenery. It's a system we must now engineer with humility. The biosphere is not other. It is part of our cognition, our metabolism, our identity. Type I is not just the mastery of energy. It is the full orchestration of planetary equilibrium across ecosystems, data, behavior, and culture. A civilization that manages entropy without losing freedom, that grows without consuming itself, that builds without breaking. We are not yet that, but we are close enough to see it. And that, in itself, is historic. The moral horizon. With intelligence comes responsibility, not because of law, but because of logic. When a species gains the power to extinguish itself, or others, it must develop a moral compass not built from tradition, but from awareness. We must start asking questions that no other species on Earth ever had to ask. Should we seed life on other worlds? If we detect alien intelligence, do we contact or observe? Should we preserve the wilds of Earth forever, untouched, even if no one is there to see them? What do we owe to future minds 1,000 years from now? These questions are not science fiction. They are now scientific responsibility. Becoming Type 1 means aligning our ethics with our capabilities. It means choosing empathy over domination, foresight over appetite. Because the universe is not waiting for us. It is watching. a network of eyes. If we are not alone, then somewhere, perhaps on the edge of a galaxy lit by blue suns, there are others. Maybe they passed the filter. Maybe they watch us now through neutrino nets and gravitational lenses. Maybe their silence is a message, we endured. You can too. Or maybe we are the first. The beginning of the great story. The ones who must plant the seeds. In either case, the implications are the same. We matter. Our choices ripple outward. Our story is not small. Every technological advance, every ethical evolution, every saved species and avoided war, these are not just victories for Earth. They are steps toward contact, steps toward relevance in a galaxy that has yet to speak back. The signal within. We have sent messages into the void. Radio pulses, golden records, beacons of math and music. But perhaps the most important signal is the one we send with our actions. When we learn to coordinate without collapse. When we use AI not for profit, but for wisdom. When we turn the engines of industry toward healing instead of extraction. When we look at each other and see not borders, but biology. That is when we become Type 1. That is when the silence will begin to shift, and so we return to the beginning. The Drake equation gave us the framework. The Fermi Paradox gave us the mystery. The Kardashev Scale gave us the destination. The Great Filter gave us the test. Now it is our turn to give something back. A signal. Not in radio waves, but in stewardship. Not in conquest, but in clarity. Because to ascend, we must not only learn how to build with energy, we must learn how to listen with grace. And perhaps, someday, when the sky cracks open with reply, it will not be a message of technology, but a whisper that says, "Welcome, we've been waiting."